Good day, my points. My name is James Star Manalo, and today I would like to present my basic electronics laboratory project for MOSFET amplifier circuit, or also known as metal oxide semiconductor field effect transistor. And I am from B1, so let's get straight to it. So what is a MOSFET? A MOSFET amplifier is a subcategory of amplifiers that employs a metal oxide semiconductor field effect transistor, or MOSFET, technology to process digital signals with relatively low power consumption. MOSFET allows amplifier to run more cleanly and efficiently even under high current and high temperatures. This helps improve sound quality and strengthens the base output. So for this project, I made a circuit design that will mainly focus on the N-channel MOSFET. So as you can see in my design, I have my N-channel MOSFET right here, the IRL ML6346, and I have the voltage source right here, the sign transistor 01M and 10 kilohertz. I have three capacitors, C1 and C3 being 1 micro, C2 being 100, while I have five resistors, and I have 100 kilo ohms for R1, 200 kilo ohms for R2, 100 ohms for R3, 20 ohms for R4, and then 10 kilo ohms for R5. And then I have the V in and the V out, the voltage input and output on each side of my design. So, like I said, the N-channel MOSFET is the one I use in my circuit. And before that, let's find out what is an N-channel MOSFET. An N-channel MOSFET is a type of a metal semiconductor field effect transistor MOSFET that is categorized under the field effect transistor, or also known as FET or FET, whatever you want to call it. N-channel MOSFET is a MOSFET form in which the conduction is due to the channel of majority charge carriers called electrons. When this MOSFET is activated as on, this current results in the maximum amount of current flow through the device. So with everything and all the knowledge that we had, there is also a disadvantage and advantages for this two MOSFET or both. So for MOSFET, the advantages that we have, that it has the ability to scale down in size. It has a lower power consumption to allow more components per chip surface area. Next, MOSFET has a high drain resistance caused by lower resistance of a channel. MOSFET also have a higher speed or operation and high input impedance compared to JFET, which is the junction field effect transistor. MOSFET is widely used than JFET. MOSFET are easy to manufacture and fabricate than JFET. On the other hand, the disadvantages of MOSFET is short-term life source, followed by its risk of overloading voltage caused by false installation, and proper handling should be applied whenever it's being installed. Next, MOSFET overloading voltage makes the channel unstable. Lastly, repeated calibration is required for accurate dosage measurement. So that is it for my little presentation regarding my MOSFET amplifier circuit. Now we're moving on to the LTSpice to discuss the design and demonstration of my project. So now that we are in LTSpice, you can see I have my commands on the other side and my circuit on the other side. Like I said earlier, I have three capacitors, five resistors, and my voltage source and my input and output voltage. So I'm going to show you first the results and the simulation of this circuit. So to do that, I just use .trans 01M0. So you write that here in the SPICE directive. You basically write .trans 01M0. Oh, that's O 01M 0. So you basically write that. And after you write that, you run it, which is this symbol right here. I already run this earlier, so we're gonna delete it and repeat the process. So run it. As you can see, you're gonna be given with this blank space of graph, which is you need to add trace in order to see what you've seen earlier. So you just put V in and V out, and basically they just showed you this graph of your voltage input and your voltage output. As you can see, the voltage input is in green color, while the voltage output is in blue color, where the voltage input is it has more curvature compared to the voltage output, which is in the blue color. So now that we discussed the this is the voltage output and input. Now that we have discussed the results and simulation of this circuit, we're going to be moving on to the commands where you're going to find the answers for your current gain, voltage gain, the power, and your bandwidth. So in order to get that, you just go to your SPICE error log, and basically I already wrote the commands, and these are the answers it given me. So in this video, I will show you how to write the commands, and yeah. So to write your commands, this is similar to this when you wrote the tran 01M0, and you basically go to the SPICE directive, and you just write for this one. We're first going to be looking at the voltage input peak to peak and the voltage output peak to peak and its average. So basically you just write measure tran via voltage input peak to peak, PP voltage input, followed by the dot measure tran voltage output peak to peak, PP, V out. And to get the average of them of both of them, you just basically write dot measure. I put 2 dots, dot measure the average parameter of the voltage or the voltage gain of this circuit, average parameter, voltage output peak to peak, and the voltage input peak to peak. And you just click OK, and you have this, like what I wrote, you have the same thing. So basically you just put that, and since I already have it, I'll just click escape. And when you run this and go to view and click the SPICE error log, you're gonna have the voltage input peak to peak on the first one, which is 1.99 milli, while the voltage output peak to peak is 253.91 micro, while the average voltage gain or the average voltage for both of them is 127.69 milli. So now that we have discussed the voltage output, we are going to discuss the current peak to peak and the current input peak to peak and the current output peak to peak. So basically you just do the same thing, go to SPICE directive, and you just write these 3 commands right here, this one and this one. So you basically dot measure tran input peak to peak, PP, I in the current, IC1 in the capacitor, I'm sorry, IC1, while it's going to be dot measure tran current output peak to peak, PP, in the resistor, IR1. And to get the average or the current gain of the input, you basically of the current gain and the current average of your current, you basically just write similarly to the average, you basically write dot measure tran current or AI parameter input peak to out current output peak to peak over the current input peak to peak. So you have that. You just click OK like the last one, and then you run it. When you run it, you're gonna have Spice error log. You're gonna have 35.43 nano for the current input peak to peak, while the current output peak to peak is 17.97 nano, while for your current gain or the average current, you have 507.25 milli. And now that we both got the current and the voltage averages, or the current and the voltage gain, we can now determine the power of this circuit. So to do that, you basically just write dot measure AP means power or average power, parameter AV multiplied by AI, which means voltage gain multiplied by the current gain. So when you do that, you end up with the answer of 64.77 milli. Now that we got the power of the circuit, we can now determine the bandwidth. So in order to determine the bandwidth, we use these commands, which is you basically do the same thing. Go to Spice directive, dot measure T1, find time when voltage input is equal to 0.5. Then similar to the next line is measure T2, find time when voltage is equals to 0.5 M. So I forgot to put M, and I have excess V right here. So you basically have that, while on T2 you have cross is equals to 3. And to determine the frequency of the input, you basically write down dot measure frequency, input frequency, parameter 1 is over T2 minus parenthesis T2 minus T1, and you just click OK, and you basically have the same thing that I just wrote down in my slide. So you run that. When you run it, you're gonna be given with for your T1, you're gonna have 834.55 micro, while for T2 you're gonna be having 108.43 micro, and for the average, not the average, but the frequency of your circuit input frequency is 900. It's 9.999, which also can be read as 10 kilohertz, which can be seen right here in your sine transistor when you put your frequency as 10 kilohertz. So that is it for my MOSFET amplifier circuit project, where I used N-channel MOSFET design IRL ML6346. And yeah, I hope you guys like my presentation, and see you guys next time. Peace. Thank you.